This episode is sponsored by Kendo UI. Kendo UI allows you to build better apps faster. They have a comprehensive library ranging from data grids and charts to buttons and sliders. Plus, you can use their components as plain JavaScript as well as in Angular, React, and Vue. They have a large collection of customizable popular themes like Bootstrap and Material. Go check them out at reactroundup.com/KendoUI.
So, Andy and Alexei, thanks for joining us. It's great to have you on. I'm excited to kind of talk about this article. Do y'all want to spend a few minutes to kind of, reintroduce yourselves to Lucas and just kind of give us a background of what Evil Martian does?
Yeah, sure. Hi, Lucas. Hi, Justin. It's awesome that you're having us on your podcast. We're very thrilled. So Alexei and I, we are part of Evil Martians. Evil Martians is a product development company that basically is a completely remote sort of community of developers. We are about 40 people. We're based all over the world. And we have a bunch of offices in Russia and in States. We have an office in New York, one office in San Francisco. We're currently moving towards American market now. And as a product development company, we basically provide a full range of services for startups, consulting them, leading them through all the stages of their business, helping them to pivot, helping them to find their customer base, helping them to scale, most importantly. So we are not the outsourcing company per se, where we work with the ready specs and implement them in code. We sort of work with the business to help them find the optimal strategy for going live. And then we follow them. And then once the startup grows, we help to coach developers on best practices, sort of provide all that services. Our clients are probably some of them, they are eBay and Groupon, more companies. And I am doing basically communications at Evil Martians. I'm responsible for the blog, Martian Chronicles, that we publish on our website, where the article that we're going to discuss is located. And Alexei is one of our most talented front-end developers. So just let's let him introduce himself. Alexei?
Hi, Justin. Hi, Lucas. My name is Alexei Ivanov, and I'm also working in the Evil Martians. I'm team lead at one of our eBay products. And so after original article, did not start as a blog post first. It was a conference talk about React and Render, but it was pretty popular, so we decided to write follow-up in the form of article.
Awesome.
Yeah, and the article is called, just to remind our listeners, it's called Optimizing React Virtual DOM Explained. And it's a very thorough primer on how React's internals work, what is JSX, what does it boil down to, and how does React make rendering decisions. And it all is supposed to help people who do React to find bottlenecks and basically understand some quick wins to optimize their apps.
The fun thing is that original conference talk was not about it. It was about working with state and how you should structure a state and how you should connect components to it, etc., etc. But the talk was pretty long, and when we started to write an article about it, we understood that nobody will read it. So we decided to split into parts, but here we are, half of the year late, and still only the first part is published.
This keep things small works really well. I like a quote from James Brown. I don't know if it's real or not, but it's attributed to him. That he said, "When I have one idea, I compose a song. And when I have two ideas, I compose two songs." So it's like if you try to put 5 ideas in one post, maybe the message won't go as far as distilling one idea at a time, right?
Yeah, that is true. I totally agree. Yes, completely.
Yes, I totally agree. But if we want to find somebody to blame for why the second article was not published yet, I will blame React guys. The second part was using Redux as example and to discuss the state management. First, I was describing how Redux work. You see context API and things like that. But then we released our first article at the end of March. And in April, React released the 16.2 version that replaced context API with the API with the new one. And it was stupid at this moment to write an article how the old context API work. So I decided, okay, let's wait. Maybe React Redux guys will rewrite Redux to the new context API, but they still didn't.
Or maybe Redux won't even be a thing, There are some talks about context API sort of replacing Redux. That's what I heard. So we're kind of waiting and trying to understand what will be up.
I gotcha. Yeah, the context API and Redux conversation is a topic for another podcast. But so this article is really, really fascinating. With the kind of wide adoption that React has, there's a large percentage of that population that probably doesn't really think about like rendering performance when looking at React. So I think this is kind of a very needed piece of content. So I like just kind of to start a little bit and talk about so what is the virtual DOM for those who might not know?
Okay, let me explain it. You see how the page is rendered in the browser. Well, basically, in HTML, we have usual DOM. It's a collection of HTML nodes that can be nested in each other, and they have some API that you can use to add elements to it or to remove them. In the time of jQuery, if you want to add something to DOM or to remove it or to modify it in some way, you just use this API. You find the element on the page using selectors or something like that. Then you just remove or add it. It's okay, but to work with DOM in browser, you need to some way to remember your current state, what is rendered, what is not rendered, or if you have some, selects, if they're opened or not. And it's quite tedious task because you need to listen and look at the state of a lot of elements. And here comes React. The basic idea of React is that you need to think about all these things. You just need to write a description of the state of the page, what you want to see as a bunch of functions. Then it will be rendered. In terms of JavaScript, it's just a simple object. So it's an object that describes your page. So it says here should be div with these classes, then it have children with some other elements, etc., etc. So it's just a big object. And then you want to change something on your page, you just run function that generates this virtual DOM again, and it creates new object. Then React compares two objects and just apply the difference between them automatically to your actual DOM. This way, we can prevent thinking about a lot of unnecessary things and just update the part of page that need to be updated and leave all other things inactive. This way, it's a lot easier to work with the interface and a lot easier to make changes.
Awesome. So one of the things that I really love about this article is that you kind of go through like a good progression between like, here's the JSX that you would write in React, and then here's kind of what the transpiled function, or here's what the JSX turns into regular JavaScript. And then you kind of like further down the article, you actually show what the virtual DOM representation of that is. And I think that's a really helpful thing, especially when we start thinking about what the process for reconciliation is of the virtual DOM, which is React's way of diffing these virtual DOM objects. So yeah, let's just talk about that. In React, when you write some JSX to represent an element, it's turned into this React create element call, and that ultimately turns into a virtual DOM node. So how does React kind of map changes to those things when it's rendering?
Okay, let's talk about changes. Well, basically, as Justin just said, the process look like that. Basically, you'll just start from writing JSX code. It's that kind of looks like HTML, but not exact. But browser did not understand JSX. So for browser to understand it, Babel or other transpiler tool transform these JSX calls to plain JavaScript. It usually function called React.create element with some params. So first of all, React calls this function with these params, and it gets object as a result of this function call. And this object is basically virtual DOM. And this virtual DOM have some standard keys that it then using to compare different virtual DOMs. Basically, every virtual DOM fragment have the key called type that it describes what element should be rendered. So basically, type can be string, div, or span, or header, or something else. And first thing that React will compare when it will try to decide to replace this element or not, if this type changed, basically. If type was div and it will become span, or if it will become something else, React will try to just replace all these HTML node and all these children, and it will not even try to do something about it. So first thing is to a type comparison. Then, if the time is the same, then the next level of comparison will start. First of all, it will look at the props k of this object and see if some of these elements will change. If the type is a string and if the type of element is DOM element like div or span, then React know how to react to props change. It will just try to replace old props with the new props without recreating element. It will just leave it in place. But if the element type is not a string, but a React component like, I don't know, your drop-down or your form component, then React will try to do some different things. It will first try to compare types, and if the type is the function and the function is the same, it will still try to run this function. It will still run its render method, or if it's function, it will try to run this function and get result. And then the result will be new React create component calls that will return some new object, and React will try to compare them to. So basically, if the type is changed, then all the part of the tree will change. If the type is the same and it's the string, then React will try to update it. And if the type is the function or class, then React will try to render it anyway.
I got you. So just to recap, when you're rendering an element, you write some JSX, and then like whatever that first thing in the JSX is, so if it's like div or it's like a component, that's going to map over to what the type property is for the virtual DOM object. And then your props will be passed into a props object, and all of that is compared. When does the actual comparison happen? This is something that I'm not exactly sure of. Is it like...
Okay, yeah, it happens this way. So basically, you have React and create component calls, and then you create components, they are not called. The thing that will call them is a React DOM render function. So basically, then you run React DOM.render. It will run the first render and will create the page. But if you run React DOM render again, with the same HTML node, but with some other elements at params, then it will first create new virtual DOM and then try to compare it to the previous virtual DOM. It's the first example, then comparison happens. But this case, it only works for calls for React DOM render, but we can also change our props and states in other ways. One of the ways how we can change it is we can change a component state. So basically, if you have components and some of these components have state and you change state, React will run React DOM render on this component render method and its children, but in ways to change it.
Yes, this is interesting because, first of all, it's a common misconception to think that React render is like initialize something and every time you would call it, it would like start all over. And it's not a thing, right? It will like React.render, React DOM.render will generate a new virtual DOM and compare to the previous one, right?
if you use the same DOM node to render it, then yes. So basically, it's the same mount point. Then it will remember that it already mounted something to it, and it will try to update it, not re-render from the start.
Yeah,
But
so it's both React DOM.render and set state. These are the two only things that trigger state, or is there any more?
Well, actually, there is still a context API, but I think it's if you start to talk about it, you'll never finish. But in normal app development, you almost never use context yourself, and you usually use either the first render from React DOM render or state changes.
Mm-hmm. Yes. So one other interesting aspect of this conversation, you talked before about the imperative way of doing it, the way we did before. Listeners and changing inner HTMLs of nodes and things like that. And it's much simpler to just say what you want and let the virtual DOM do the updates. But a question that may arise is like, is there any real world case where it does not work well? Like, what are the trade-offs? What would be the situations where we would not choose to use a virtual DOM algorithm? Have you ever encountered one?
Well, you see, it's a good question. Let me start from some background. So basically, if you are working with the single page applications and you have a lot of changes in the browser, then I think that using Virtual DOM and some its implementations like React Render or something in Vue, it's probably the simplest and most easiest way. But there is a lot of case in real world. Then you just need to have some small little changes to the page that should be rendered on the server side, and you didn't want to add a lot of JavaScript to your bundle. For example, a lot of sites need to have a server-side render to work with search engines. For example, if you're creating a e-commerce site or some landings, you probably want for search engines to index you. And they probably did not have that much interactive stuff happened on the page. It would not be the best idea to bundle all of the React to your bundle and to add a lot of logic that works with React to just, show pop-up or to add something to the cart. It can be easier to just do it all the way.
I get you. Yeah, that makes a lot of sense because if it's pretty basic, then you don't have to do a whole lot of manual updates of adding and removing nodes.
Yes, exactly. Because for React to be able to use Virtual DOM, it needs to understand the current state and new state and basically all the page structure. So to make it work, you need to write all or most of the page in React and then bundle all these components to your bundle. So React can load them and make comparison and then decide that it should show this white box or pop-up. And I think it did not have a lot of sense to do it.
This is a good answer. I never worked with these types of projects, but I also heard that when we have these projects that are very real-time based with WebSockets connections and needing to update hundreds of elements in real time on a screen that sometimes the virtual DOM is too slow for the updates, and then you cannot escape the manual way of doing so. You need to be very precise about what you're going to update with that thing, this big, financial data dashboards in real time. I've never worked in a project like that, but yeah, I've heard some people saying that they had a lot of performance issues, but I'm pretty sure that 99.99% of the applications actually will perform better with a virtual DOM than after a bunch of listeners and inner HTML here and there. Things get very complicated pretty soon. So, yeah.
You see, the fun thing is that it should be in the second part of our two-part article, and it was in my talk. Because the reason that I start to dive in the React and render is because we have the project there, we have a big table that we wanted to update in more or less real time. And our initial implementation of React components was not fast enough. So we start to dig in the raw DOM compassion algorithms, or to try and shoot component updates for pure components and things like that. And the point is that, yes, if you re-render all your page all the time, for example, if you have, one connect at the top of your application and just send all your data inside of it, and then you try to, enter something in input on the page, then for each entered symbol, you need to calculate all of the virtual DOM, and each would be very slow. So the good practices here is to structure your state in the way that you can update it without affecting your data structures or your neighbor object and things like that, and have a lot of connect on the low level near the element that is updated. Basically, you need to wrap all your table lines or even inputs in separate connects and just supply them with the data they needed. And this data should be simple strings and numbers, and you should avoid object and things like that. This way, it will still be fast.
So that's just to reduce the amount of state changes so that you're reducing the amount of times that render actually happens, right?
Yes, the closer connect or state change is to the components, the smaller part of the page should be re-rendered. So the smaller part of the virtual DOM should be generated and compared, and it will become faster. So,
do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device, on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says pay me now. And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section.
Right. That brings up another good point of reading through the article. So we talked earlier about how type was kind of the first thing that was checked when a virtual DOM node is being rendered out. So if you're rendering like a div or a span or something that's like a native element, then it'll check the type, and type will be a string. So you have like a div, that's a string. And then on the next render, if it's like also a div, then those are like equal. So it uses like equals, like strict equal comparison to like compare these types. So two divs would be equal. Obviously a span and a div would be different. So it would just like throw out that element and kind of re-render it. But what was really interesting is, so for like class components, they're not always equivalent, even though they're the same thing, because they could be different instances. So do you want to talk a little bit about that? That means that you're going to, is it always going to re-render for those components? And what can you do to control the render lifecycles for those who might not be aware?
yes, of course. Well, basically, we need to talk about two things in this example. First of all, in my article, I have example, then you are using high-order components. High-order components is a great pattern. Then you take your component and wrap it in the function, and you have a new component as results that have some enhancements. It's cool. It's used all the time. It's used inside pretty much every library that you can find. and it's hard to develop React application without it. But then you're creating a new high-order component. You need to remember that the function that creates high-order components from other component is always create new function that will be called. So basically, if you wrap, your button with some connect, then the result of this connect will be a new function. And this new function, and after each connect call, this function will be new and it will not be equal to the previous one. So if you, for some reason, create your components inside the render method, then they will be a new instance of this component each time. And then React will try to compare virtual DOMs. It will think about these components as different components and will just disregard all these three parts and will re-render it from the start. So to avoid it, you should only create high-order components outside of the render calls. So they will be just created once and just used. It's pretty simple to fix it, and it will save you a lot of unmounting and mounting the nodes again. It's the first problem. But as Justin said, if type of the component in virtual DOM is function of class, it will be called each time, even if the type is still a function. It will not replace the DOM nodes, and it will not call for a page repainting and removing and adding nodes. But the virtual DOM part of this page will still be recalculated. So it will still call render and still return some functions from this render and some JSX components that will still be called and compared. And it's not always a good thing. And if you know that some part of your application will neither change or will not change if something in the top-level component changed will affect it, then you can just prevent this part of the tree and these components to render. You can use a should component update function for it. How it works. Should component update is a method of the class based React components. So if this function receives the new props and state, and you can compare them if old props and state, and you can decide yourself, should this component be rendered or changed? If you return false in this method, it will not be rendered. You can prevent a lot of virtual DOM recalculations and updates this way.
Cool. Yeah, that's a really, really beneficial tool to just controlling your rendering. And part of your article, you also showed how to use the React DevTools to kind of show when there were updates to rendering cycles. So we'll include the actual link to the article, of course, in the show notes. And I definitely recommend people go kind of like read through it and check out that particular function, because it's really beneficial to kind of see like how things are actually rendering. Because sometimes things are rendering more than you would expect.
Yeah, this is a very interesting topic to me because we have things that apparently help us in principle when we are creating an application and we need performance. And so like, we use a pure component, which is a component that already has a should component update implemented for you with some basic comparison functions and things like that. But in the end, this is a message I try to carry around. Like, we need to open the performance tools. We need to open DevTools and understand what is happening. Like, is it really a bottleneck that I think it is, and things like that. Sometimes we are optimizing our application. So an interesting case, it was, I don't know, like some months ago, there was like a really big Twitter, one of those Twitter things of people saying you should not create functions on render, right? So people are using anonymous arrow functions on render as callbacks. So these functions will be created every time render gets called. So you should create a method function and just pass this method function to the props. but it's not every time this is going to result in better performance, because sometimes you're not going to call that render function a lot. Sometimes you won't call the render function that particular component in most of the page views. You are allocating that function on page load for every page view. So we need to use those perf tools to understand like which components are our bottlenecks and try to focus on them and use these techniques that you talk about in your post. Yeah, it's like performance work should always come with profiler work, right?
Yes, exactly. It's pretty much that I was always trying to say. Don't think about optimization before the things slow down. Just develop in the way that makes sense for you. If something starts working slow, please don't try to optimize everything. Profile things, understand what is the bottleneck, and fix it first. After that, profile it again, and if it's still slow, then look at the next bottleneck, etc., etc. It usually did not that good idea and not that useful to fix every possible place that have some slowdown. Because, for example, if you, as I said before, have a lot of connected components that update their states and did not update and have should component of the updating them or the pure components, then you can save some time in optimizing the children. So basically, if your table row is a pure component and it will only render, then its props will change. Then you don't really need to optimize functions inside of it, because it will be only called if this row data changed and it will only affect one function. So you can save some time on it, things like that.
Yeah, cool. So not to veer the conversation off too much, but we've been talking about like render performance, and Lucas had mentioned the pure component and, you know, not creating functions in render and things like that. You actually have a big quote in the article. It's like, if you're mindful of creating objects, arrays, and functions outside of a render definition and make sure they don't change between calls, and, you know, you're safe from like a rendered performance perspective. This like brings up a really big question for me. So there's a really common pattern these days in the React world that I'm seeing, which is function as a child component, where you have a component and then the child of that component is just a function, and the kind of the parent component is basically just calling that. So that is essentially creating a function in a render function. And I'm just curious about that pattern. Will that re-render every time? Is that because of its render performance? Is it kind of an anti-pattern? Or kind of what are your thoughts on maybe that pattern and like optimizing and things like that?
It will render each time if some of its parents or this component itself changed. And then, yes, it will try to change its children. It's not always anti-pattern, because if you did not change the parents that much, or you change the children by connecting them to store without them taking data from their parents, then it can be okay, because if you did not call this update too often, well, it's not that much of a problem. But you need to remember about it all the time, and you need to profile all the time to be sure that you didn't change something in the upper part of the application, because you can change a lot of things that you probably didn't want to change this way, and to cover a lot of renders.
Yep, I think that's a great point. Always profile.
Yes. My only issue with the render props pattern is not a performance issue. It's more architecture issue. A lot of the times we want something to be injected. Like we use most of those to inject some functionality, right, in our application. Something like I'm listening to some window size change, or I want to have some access to, I don't know, Apollo client or things like that, to a function. Sometimes we want to access those outside the render function. Sometimes we want to access those on a life cycle, like on component mount. The higher order component makes it simple, makes it easier to just add a prop to a component, and then it's easy to access it on the life cycle methods. That's probably like the only reason I'm still creating a bunch of higher order components here and there, because sometimes I want to call things on the life cycles, and I don't want like to create a component to have it on a render function and then pass it to the props to the component I needed. That's my only complaint with render props personally.
Well, it's work most of the time, and if you can do, well, of course, do it. The only case that it's not really working is if you have not one child component, but a few child components that need to use these props. So if you have a few child and each of them want it for some reason, this way to receive them from function will make it easier. So,
yes, you mean like composing consumers, right? Composing a bunch of render props.
Not exactly. Well, you see, what we are talking about is then component return function as a children element. And this function call will receive some properties from its parent, for example, height, width, or something else. Mm-hmm. And now we need to send this height, width, or something else to some of its child. If it's just one child, it's easy. You can just send them as props to this child. But there is some examples when you have big components that itself is composed from few components, and each of them needs to receive just part of these props. So instead of wrapping each of these components in high order components, it's easier to just render them as function and just manually assign the values to each of them.
Yep, I agree. Yeah, that's a good use case.
Yeah, there are some interesting cases with that pattern where things that I've seen where you have like a lot of those that are chained together. So like it becomes this kind of funny tree of like function. It's like there are some like higher order components that will help you compose those function as child components into kind of one and like join the props and everything. But it's kind of interesting to look at some of that code sometimes. So
yeah, it's like callback hell all over again.
It can be.
Yeah. We keep put ourselves in the same traps. But yeah, everything's always a trade-off, right? Like it brings a lot of benefits, but you need to seed somewhere. And I believe the render prop seeded on the usage in lifecycle components and composition. But yeah, every time I can use it, I use it instead of the higher order component, because if we start to look at the internals and looking at the debuggers and stuff, even the tree, after the tree is built, it looks cleaner with render props. I like it, even with the drawbacks.
Yeah, I totally agree too.
So, hey, I have one more question. There's one more thing that I really wanted to talk about because I think it's kind of an interesting thing. So you spent some time talking about kind of like lists of like children and how if one of the children are removed from that list, that array, then it ends up like re-rendering kind of all the children because it's like trying to compare their positions. And you mentioned key as one way to deal with that. And you also mentioned another alternative of using a Boolean flag to deal with it. So I want to talk about keys for a second. So pretty much every time I see somebody use a key, they're always using like an index of this array that they're iterating over, which is kind of seems like it defeats the purpose of using the key. So I really want to hear your thoughts on that.
You're absolutely right. Using the index is pretty much defeats all the purpose of it. I think that they just use it because else React will post these nasty messages to your console saying that just add indexes and don't do it. But the basic idea of keys is that then you change the order of the elements in your array. React should know which elements in array to compare with each element in the new array, and it's use the keys to compare them. So if you're using indexes instead of keys, then it will just compare wrong elements, and it will find out that they're different, and will just redraw all of them, and you lose all the benefits of using keys.
Great. That's something that I kind of see continually, and I try to bring up in pull requests and things when I see it. But it's like a smaller known thing. But you're absolutely right. Most people just like, I want this keys error to go away, so I'm just going to like find something I can shove in here without kind of understanding like what it's doing. So to some extent, it's good to know if your tool requires you to do something. It is good to know why it's requiring you to do something.
Absolutely.
Cool. So those were my big questions. Does anybody have anything else before we move on to picks?
Yeah, just one last question. And this is a question towards a common beginner struggle too. Is that so the person is starting to program and start to be a web developer, and you say like, okay, you're learning React. This is a good tool. This is the tool that people are using now. And then the person is learning how to build an app with React. Then we start like throwing articles on them saying like, oh, here is how things work under the hood. And a lot of times I think that when people are still trying to understand like how to use React, and then when they also learn like how React works, sometimes it's like a cognitive overload on the beginners, right? So do you have any experience with that? Like, when should we dive inside React? How can we prevent this cognitive overload of now I'm trying to build my application, and at the same time I need to understand all this virtual DOM stuff that React says that it handles for me for free, and now I need to learn about those things. Like, what would be your advice for people starting out?
If I might, before Alexey continues, this is rather philosophical question, like how beginner should you be before you start learning React, right?
Yes.
And if you are already learning React, then, like in my opinion, ideally you should be very well aware of JavaScript at that moment, right? So jumping into React without knowing a thing or two about JavaScript, this is, I think, a common mistake that a lot of people are doing nowadays, trying to just catch up to something shiny. And then I think if you already had a chance to play with things like, at least I think anyone learning React should try to update elements in the DOM manually, just before trying React. And then with that knowledge, I think understanding the internals would be much easier. But yeah, this was just my 2 cents. Alexey, what do you think?
Okay, there is 2 common scenarios. First of all, it's complete beginners in JavaScript and front-end development. And showing them article like mine and wanting them to understand what is these different algorithms and things like that will not be really useful, and it will probably lead to cognitive overload. So for them, the first thing that they should do is to become familiar with basic React concept and JSX and just try to do things. And for some time, they'll be okay, and we'll be able to build some application and see that stuff working and be happy about it and do some, have some results and useful application. But at some point of time, it will start to show problems and will become slow and unresponsive. And it's probably a good moment for them to dive in the articles that describe the inner workings of it and then understand why this slowdown happens. It's one thing. But there is other case. Then somebody who already know JavaScript and worked with jQuery and DOM and different things was starting to learn React. And he see a lot of new and strange concepts like JSX and etc., etc. For them, it can be a good idea to start with articles like this one to understand how these concepts maps to the things in JavaScript they already know. and maybe it will be easier for them to learn this way.
Yeah, I find both answers very interesting. One thing that I always try to do, and I always try to do like this in life, not always we can do it, but when we can, it's really good. Whenever you are going to hire someone to do something, or use a tool to do something, or choose a framework, or buy a product, always try, at least for a little bit, to do the work itself without it. Because that's what you're saying. Like, if you try to build an application without React, and then when React is introduced to you, like, you're only going to see the benefits that they're bringing, or at least the trade-offs, the choices that are being made. So one thing that happens a lot inside the React world itself is the same thing. People that do not write an application with React and start writing with Redux right away, it's the same thing. Like, you cannot understand well the benefits of Redux without doing a bunch of React applications and see the moments where that thing breaks. So this input is interesting. So whenever we have a chance to start with the basic building blocks and then building up, yeah, that makes sense.
Awesome. Well, if that's all we have, let's move on to picks.
Is your job search stuck? Maybe you're not getting any interviews with employers, or maybe you are, but no job offers. Or you may be new and not even know where to start. This is Charles Max Wood, and I'm releasing a new course and ebook on how to find a job as a software developer. The course walks you through the process of finding the types of companies you want to work for, getting their attention, and putting your best foot forward as the candidate they want. I've coached dozens of developers in looking for jobs and have been able to help several people find jobs within 2 weeks to 2 months. So whether you're new to development, can't find a great job that fits what you want, or are looking for remote work from an area without a strong tech community, I can help. Go to getacoderjob.com and sign up today.
So, Lucas, would you like to kick us off? Do you have any picks this week?
Oh my God, I was caught by surprise here. So my first pick is try to check if the room you're going to record anything has a really weird echo or not. So be aware of the echo. It seems like I'm talking from a cave. So yeah, check our stuff first. I don't have any picks this week. This would be my only one.
All right, cool. Andy, do you want to go? Do you have a pick? Anything you'd like to recommend to listeners? Books or anything?
Thanks for sharing. Well, me personally, this week I've been reading a lot about the Go programming language. I don't know how it's going to be interesting for people who are doing front end, but why not? Maybe, we're a full stack here. We have listeners interested in different languages. Definitely, I'm enjoying a lot looking at Go and just playing with its concepts and listening to Rob Pike's talks. So probably, yes, discovering the whole community and the awesome documentation behind the language and all the conferences about it. It's a big pleasure and a very nice surprise, to have like something that is mapped out so well when you're just beginning discovering something new. I would think that's a very good example of like introducing a concept, what Go's team does to attract beginners.
Awesome. So, Alexei, do you have anything?
There is a really cool book called Understanding Comics by Scott McCloud. And it's not about comics, but but a big part about life itself. And what the fun thing is, it's all answers the Lucas questions pretty well. It's have a section that talks about the education and how we try to teach people different things and how people actually teach learning. Basically, we are usually trying to teach people new things, starting from a big concept about things like composition. And in the case of comics, we start with story and composition, and then we're going to the smaller things like pages and pictures and them, etc., etc. But then people try to learn something they did not want to spend a lot of time on preparation work. They want to just start drawing, and most of the people who really draw comics, you start by drawing pictures, and then after that going to draw the pages, and after that to the books, etc., etc. So coming to Lucas' example, I think that for people who are learning something, they just need to get their hands on it and start trying it. And we did not need to teach them before how compilers work and how browser works and how things work under hood and some core programming concepts. Just let them play with the things and have some results. So if you want to understand comics better and learning things better, well, the book Understanding Comics by Scott McCloud is a good place to start.
Awesome. So for my pick, I've been learning Elixir recently, and it's been pretty fun. So there's a Udemy course that was on sale. It might not be on sale by the time this podcast goes out, but it's been a great resource for me. It's the Complete Elixir and Phoenix Bootcamp if you're interested. But Elixir is a pretty fun functional programming language. So if that's your kind of thing, then definitely check it out. Cool. And with that, I think that's everything. So thanks for being on, and thanks for talking to us about the Virtual DOM and rendering performance.
Thank you, Lucas. Thank you, Justin. Thank you for having us. It was a pleasure talking to you guys.
Cool. All right. Thanks, everybody. That's all we got.
Thank you.
Bye-bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.